Hi dear students. So next we are going to learn what is called the nomenclature of isocyanates. So in my previous lectures we have explained almost everything. We are going in a sequential way. So next comes after cyanates is isocyanates. Actually this is not in your syllabus. You just want to know it. There is no isocyanates or its preparation reaction. You don't want to learn it, but just we will go through the fundamentals. Okay. So the isocyanate representation you could see here, it is NC. Okay, so you could see between N and C there is two double bond and one coordinate bond is there. If it is represented by an arrow, it indicates coordinate bond. Okay, I will explain all these bonds in chemical bonding. Okay, now here the suffix used here is isonitrile. What is the suffix used? Isonitrile. When we will use this, if the carbon atom of the isocyanide is included in the parent carbon chain. So here many students will have a doubt, sir, it starts with N and here it is C. So it is not the carbon which is connected. Then why we need to include this carbon in the parent chain? This is a common doubt, but as per IUPAC, it is considered like this carbon atom is present in the functional group, and we can say it like this carbon should also be included in the parent chain. Okay. So that is means if the carbon atom of the isocyanide is included in the parent carbon chain, the suffix used will be what? Isonitrile. What was for cyanide? It was nitrile. Okay. If this carbon atom is included, in that case there is no prefix. Prefix is not applicable. That means the isocyanide will not behave like a substituent if that is part of the parent carbon chain. Now next thing, the suffix can also be carbylamine. The possibility is carbylamine. When we use this suffix, if the carbon atom is not included, we have seen sufficient examples. I will also give you example when this is not part of the parent carbon chain. So at that point we use the term carbylamine, and in that case if it behaves like a prefix, we use the term isocyano or carbylamino. Both are correct. So in some questions you can say they are using when it acts like a substituent, they are using the term isocyano, or in some cases you could also see they are using the term carbylamino. Both are correct. Okay. Now let's see one example. So you could see this question. So in this question, this is my parent carbon chain. Okay. So how many carbon atoms are there? 1, 2, 3. So 3 carbon atoms are there. So what is the common name that will come? Suffix name usually alkyne isonitrile. So here alkane, how many carbon atoms are there? 3 carbon atoms. So my word root is prop. Correct? All are linked as single bond. So we use the term propane. Then the suffix is isonitrile. Okay. Here also students will have a doubt, sir, here N and C are linked by triple bond. No, you should not do that. Here you need to consider only without the functional group the other carbon atoms, how it is linked. That is the reason why ane is coming. Okay, that is the common name we are saying, not the common name, the suffix, the usual suffix name, that is alkane isonitrile is the common suffix name. So here you can see alk means prop, ane isonitrile is coming. Okay, now similarly you can name this. How many carbon atoms are there? 2 carbon atoms. So parent chain, this is one. So it will be ethane isonitrile. Understood? So please remember this. Not very important, but you just need to know. So whenever it behaves like a substituent, the term will be isocyano or carbylamino. Okay, I hope you understood. Next we will go to the nomenclature of next organic compound. Okay. Hi students, so the next in the list is nomenclature of aldehydes. Okay, so what is the common way with which we represent aldehydes? It is CHO. CHO also has carbonyl group C double bond O H. This is the actual structural representation. Now if you look at aldehyde also, it is also a carbon containing functional group. So there are two possibilities. So if carbon is part of the parent carbon chain, that is it is included in the bracket, in that case we use the suffix al. Okay. Suppose in this case the prefix used, in this case suppose CHO is present along with the carboxylic acid COOH. In that case what will happen? COOH becomes the parent, correct? In that case COOH will become the senior most functional group, and its suffix should be used. And this CHO carbon atom is also there in the parent carbon chain. In that case, we know that CHO will behave like a what actually prefix or substituent. In that case, we use the prefix oxo. I will give you an example, then you will get a clear understanding. Okay, look at this example. I am giving an example for this one. Something like this. Can you name this compound? So if you look at this typical example, you can see here CHO is present, also carboxylic acid is present. So who is the senior most one? Carboxylic acid. But we select the parent carbon chain like this, correct? So we need to include this carbon also. In this case, the carbon atom of the CHO is included, but still it is behaving like what actually? A substituent. So in that case, we can use the prefix actually. So the prefix used should be what? Oxo, if the carbon atom is included in the parent carbon chain. So what is the name? You can give here, just I will number it 1, 2, 3. So what is the possible name? I can say 3, it's a substituent. So first 2-degree prefix means 3 oxo. How many are there? 3 carbon atoms. 3 oxo, prop, all are linked with a single bond, propan, 1 oic acid. Understood? So that is the way we need to name this compound. I hope you understood. 3 oxo, propan, 1 oic acid. Now comes the next case. Okay, so in the next case, how we can say, listen, suffix is used is carbaldehyde. So when this suffix will be used, if the carbon atom of the CHO is not included in the parent chain, and this will behave like a functional group. The common example you might be knowing here, if the compound is like this. I have given you examples like this earlier. So in this case, CHO is present outside the ring and it cannot form a parent carbon chain. So this will be the parent. So I can say cyclohexane. Since this carbon atom is not included, we use the suffix carbaldehyde. So then IUPAC name of this compound is what? Cyclohexane carbaldehyde. Understood? Okay. So there can be cases where the carbon atom of the CHO is not included in the parent carbon chain and it is behaving like a substituent. So in that case, we use the prefix formyl. So please understand, this prefix formyl is used if carbon atom of the CHO is not included in the parent carbon chain. Okay, this prefix is used if the carbon atom of the CHO is included in the parent carbon chain. Okay, we will see the examples, then you will understand this. Okay, let's see the example here. So how will you name this compound? CH3CHO, easy example. So I know that carbon atom should be included in the parent carbon chain, correct? So what should be the name? So two carbon atoms are there, so it should be eth. All are linked with a single bond, ethane, and I know at first position you have, so ethane 1R, since carbon atom is included. Okay. Now here only one carbon atom is there, so I can say meth, only single bond, so methane, and at first position 1R, methanol or methane 1R. Both are correct. Okay, so I hope you understood the concept. Now we will try to do more questions. Then you will get a clear picture. Okay. Okay students, so let's try to see some examples. So then you will get a clear picture. Okay, so in the first example, you could see here, as per our convention, what is the first thing we will check for? Functional group. Yes, it is present. It is a carbon containing functional group. Then the rule says that you should select the parent carbon chain starting from that. Then what needs to do? Longest possible chain. 1, 2, 3. 3 only there. 1, 2, 3, 4. Yes, this is the longest one. So I will choose this as my longest continuous parent carbon chain. Correct? Now how I will number it? This should get the minimum possible number 1, 2, 3, 4. So what should be the name of this compound? First 2-degree prefix will come, that is 2-methyl, correct? 2-methyl. Then 4 carbon atoms, so the word root should be but. All are connected as single bond, butane, correct? Then at first position you have R, butanol. So this should be the answer. Understood? So we will go to the next question. We will go to that question very last. We will go to this one. Okay. So here also we are looking here, functional group is present. So here, and we know that it's a carbon containing functional group, so we will start from here. Then we will try to choose the longest one. 1, 2, 3, 4, 5, 6, 7. So this should be the longest path. Correct? So I have chosen that. Now I should number it in such a way that this should get the lowest possible number. 2, 3, 4, 5, 6. 6 carbon atoms are there. Now tell me first the substituent at 5th position. So 5, that is a second degree prefix. 5 chloro. Word root, how many are there? 6, so hex. And at the 3rd position it is linked by triple bond, so we say hex 3 yn. At 1st position there is a 2 degree suffix 1 al. Correct? So 5 chloro hex 3 yn 1 al. There is no e here, please remember, 3 yn hyphen 1 al. Understood? So coming to the example 3rd one, this one. So how will you do this? Very important. So if you see here functional groups, 3 functional groups are there, COOH, CHO, OH. So I know that who comes first top in the priority table? COOH. So this is the functional group, and these two will behave like what? Substituent. OH and CHO here behave like a substituent. So I should start from here. Now choose the longest possible path. 1, 2, 3. 3 only. 1, 2, 3, 4. 4 only. 1, 2, 3, 4, 5. Okay, this looks the longest path. Please remember, now CHO and OH are behaving like just substituents. Okay. So I have included this. Now you could see the special case. Here in this case, CHO is behaving like a substituent and the carbon atom is not included in the parent carbon chain. So in this case, what is the prefix should be used? Formyl, because the carbon atom is not included. So if the carbon atom is included in the parent carbon chain and if it is behaving like a substituent, then only we use the term oxo. Very, very important. So here OH also behaving like a substituent. Whenever OH behaves like a substituent, the prefix used is hydroxy. You could see that. Okay, so numbering, so 1, 2, 3, 4, 5. So can you name it? So I know 2 for methyl is there, 3 formyl is there, 4 hydroxy is there. Who will come first in the alphabetical order? Methyl M, formyl F, hydroxy H. Who will come? Formyl. So I can write 3 hyphen formyl hyphen, then who will come next? HIJKLM. Correct. So 4th position hydroxy, 4 hydroxy. Correct. At 2nd position methyl. Correct. So this much substituents are there. 3 formyl, 4 hydroxy, 2 methyl. Now the word root. How many are there? 5 is there. So I can say pent. Correct. All are linked with a single bond. So pentan. 1st position oic acid. 1 oic acid. Okay. 3 formyl, 4 hydroxy, 2 methyl, pentan, 1 oic acid is the name. Okay. I hope you understood. Very simple. Identify the functional groups. Locate this in the priority table. Who comes first? That will get the first priority and that will behave like a functional group and others will behave like a substituent. Nothing else. Okay. Substituent means pure substituent. Don't give any other importance for that. Okay. Now comes the next one, a special case where benzene I have introduced. So this structure, this is called a special compound benzene, very important. We will learn this. So just to know that this compound is what? Benzene. You will learn this. Okay, please learn like this. This is benzene. Now another way of representation of this is called this way. We will try to learn why it is like this in our chapter hydrocarbons, don't worry. So this is benzene, this is also benzene, 2 representations. Now into the benzene CHO is attached. I know that this carbon atom also cannot be included in the parent carbon chain, or this cannot form a parent carbon chain. So in this case, what is the name? I can say that the name should be benzene. Since this is not included, we use the term carbaldehyde. Carbaldehyde. So this is the correct name, benzene carbaldehyde. But some older scientists, they used to call this compound as benzaldehyde. This is also correct, but latest IUPAC recommends this to be benzene carbaldehyde, more correct, because the carbon atom of the CHO is also should be told in the parent name. Okay, So I hope you understood the whole concept. We will try to see more questions, don't worry about it. Okay. Hi students, so next we are going to deal with the nomenclature of ketones. Okay, so the ketones is represented by C double bond O. So it's a bivalent functional group. What do you mean by bivalent? So here also something should be attached and here also something should be attached. So there are two valencies free. So such compounds are called bivalent functional groups. Okay, here one more important thing with respect to ketones, this C double bond of functional group is always this should be included in the parent carbon chain. If it is coming, it can be between two compounds. So whenever you are selecting the parent carbon chain, this will always come here. Okay, so if it is a part of the parent carbon chain, then we use the suffix 1, O-N-E. There cannot be a case where this cannot be included in the parent carbon chain as a suffix. Okay, suppose if it is not included, for example, if this C double bond O comes along with COOH, in this case, I know that C double bond O will behave like a substituent. In that case, I use the prefix oxo or keto. Okay, for example, I will give you an example always for those like questions. Okay, see here, a case like this, CH3, C double bond O, okay, CH2, COOH. Now how you will name this compound? So I know that this is my parent carbon chain, correct? This is my parent carbon chain. Now this 1, this goes 2, this goes 3 and this goes 4. Now I know that carbonyl group as well as COOH group is there. Who comes first in the priority table? COOH. So this got the seniormost priority. So this is the functional group and here C double bond O will behave like a substituent. In that case I should use the term, I should say the prefix should be used. So this is a substituent means first I should say that 3-oxo. Either I can use oxo or keto. Both are correct, but in majority of the questions I could see oxo is being used. Or sometimes keto. It's both are correct. So 3-oxo. The word root is 4 carbon atoms means but. All are linked with a single bond. Butane. So first position oic acid. So this should be the name. 3-oxo butane 1-oic acid. Understood? So this is the case where C double bond O behaves like a substituent. Sometimes this will not be there. For example, if I am taking this case, here you know that only this functional group is present and this is my parent carbon chain. And you can see that in all these cases carbon atom is included in the parent carbon chain. So numbering should be 1, 2, 3. Okay, and another important case of carbonyl group is never one will come to carbonyl group. Because it always lies between two other carbon atoms, it will get any number other than 1. Very, very important. So how can name this? Parent 1, 3 are there, so I can use prop. All are linked with a single bond, so I can say propan. Then first position 1 on. So the suffix on should be 1 should be used. So propan 1 on or propanon, both are correct. Understood? So in this case, how will you number it? So this is my parent carbon chain. So here numbering you should be taking care. So if I number it like this 1, 2, 3, 3 will come. If I number it like this 1, 2, so minimum number should be there 2, 3, 4. So what is the name of this compound? Butane 2 on. Understood? So I hope you understood the fundamentals of ketones. So we will see some examples. Okay. Hi dear students, so let's see some examples of nomenclature for IUPAC nomenclature for ketones. So in the first example you could see CH3, CH, CH3, C double bond O, CH, CH3, CH3. So how should I choose the parent carbon chain? I should include this carbonyl group. So I know that 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So both are correct. So either I can choose that one or this one. You will get the same name. Okay. Suppose if I am choosing this. Now how I should number it? So if I go it in this way, 1, 2, 3, 4, 5, 3 is coming. If I go it in this way, 1, 2, 3, 4, 5, again 3 is coming. So 3 is fixed here, correct? 3 is fixed. So if I go in both way, both are methyl group. So there is no difference. So I can start from here, 1, 2, 3, 4, 5. Okay, so how I will name this compound? Tell me. First comes 2 degree prefix, that is the substituent. At 2 and 4 position you have methyl, so we say 2 comma 4 diamethyl. I will say 2 comma 4 hyphen diamethyl. Correct. Now the word root, there is no 1 degree prefix, you know it's not a cyclo compound. So 5 carbon atom means pent is the word root. All are linked through single bond, so penten, correct. At third position you have the 2 degree suffix 3 on. So my answer is 2 comma 4 dimethyl penten 3 on. Understood? Now we will go to the next example down. Okay, so here also it's a straight example. Choosing the parent carbon chain is easy. So this is my parent carbon chain, correct. Now if I am numbering it, there is at the second position you have a double bond. If I go in this way, you have functional group. So functional group should get the priority. So this should be 1, this should be 2, this should be 3, this should be 4, this should be 5 and this should be 6. Correct? So what should be the name of the compound? Tell me. We know that there is no 2 degree prefix, there is no substituent. 1 degree prefix is not applicable since it is not a cyclo compound. So the word root is hex, correct. Now at the fourth position you have a double bond, so hex hyphen 4n, correct. At the second position you have the 2 degree suffix is there, so n2 on. So my answer is hex 4n 2 on. Some people used to say 4 hexen 2 on, that and all not perfectly correct. This is the correct answer, hex 4n 2 on. Understood? Now before we go to the third example, we will try to do this one. This is a cyclic compound. Here also you could see the functional group is keton, correct. This is CH2, this is CH, so carbonyl group is coming. So we should number it in such a way that keton functional group should get the lowest possible number. So 1, correct. Then double bond is there, so it should get the priority. 2, 3, then 4, then 5, then 6. So what should be the name of this compound? Tell me. Since it is a cyclo compound, we use the term 1 degree. Who will come into picture? 2 degree prefix is not there. Why? Because there is no substituent. 1 degree prefix is applicable because it is a cyclo compound. So it is like, can you tell me? So cyclo, correct? Cyclo, 6 carbon atoms, hex. At the second position you have a double bond, hex hyphen 2n, and at the first position you have the 2 degree suffix, 2n 1 on. So answer is cyclohex 2n 1 on. Understood? Now coming to the last example, here functional group C double bond O is there coming with a substituent. So this will get the highest priority. Then I know that next priority there is no double bond. Then who will get the priority? Substituent. So 1, 2, this should be 3, this should be 4, this should be 5 and this should be 6. If you go in this way, this number will be more than 3. So that's the reason why as per the lowest locant rule I am going like this. Okay. Now what is the name of this compound? Again it's a cyclo compound, so cyclo, correct. 1 degree prefix is applicable. Cyclo, hex, correct. Hex, all are linked with a single bond, so I can say hexen, correct. Okay, I forgot one thing. There is 1 degree, 2 degree prefix is there because there is a substituent. So I should start with 3 hyphen methyl, correct. Then 1 degree prefix is applicable because it's a cyclo compound, so I added the term cyclo. Then word root hex is there. Then 1 degree suffix, all are linked with a single bond, so an is there, and 2 degree suffix, that is at first position on. So the answer is 3-methyl cyclohexanone or 3-methyl cyclohexane 1 on. Both are correct. So I hope you understood, and we will come to the last example, very important. So here you can see 2 COO group is there. So again this is my parent carbon chain, there is no doubt in that. So in this case, how many are there? 4 carbon atoms are there. So we use the term but. All are linked with a single bond, so we use buten. Please remember, whenever more than one C double bond O group is there, similar to cyanide group, we should add E here also. So butane. Then I know 1, 2, 3, 4. So I can say butane hyphen 2,3 hyphen dione. Okay. So Hi students, so next we are going to learn the nomenclature of alcohols. So first time we are going to meet a group that does not have a carbon, correct? OH is the representation, so it's not a carbon containing functional group. Okay, so in this case it is very easy. Suffix used should be whenever OH is the only functional group present there, or OH is the seniormost functional group. In that case the suffix used should be all. Suppose the OH is behaving like a substituent. In that case, what is the prefix we need to use? Hydroxy. Understood? So you can see here hyphen OH, or this means radical. This is where you need to connect your group. So it's a monovalent functional group. Monovalent means one valency, you could see here. Okay. Now we will try to see how the questions we need to identify it, right? So you could see here OH group is connected here. So this is my parent carbon chain, correct? So what is the rule stating? Whenever the functional group does not include carbon, then that functional group will be connected to some carbon atom, right? That carbon atom should be part of the parent carbon chain. Okay, so here OH is connected to this carbon, so I have included that carbon in my parent carbon chain. So what should be the name of this compound? While numbering, I should ensure that the functional group should get the lowest possible number. So 1 here, so here 2, here 3, here 4, here 5. If I go it in the other way, OH will get a higher number. Okay. So what should be the name here? I know that there is no substituent. It is a linear compound. So what? 2 degree prefix and 1 degree prefix not applicable. So 5 carbon atoms means pent. All are connected through single bond. So pentant. At second position you have OH. So pendant to all. Understood? Now coming to the next one. I know this is my parent carbon chain. Correct? So I should start numbering from the carbon atom where OH is connected. 1, 2, 3. So that should get the lowest possible number. Now what should be the name? 3 carbon atoms. So prop. First position there is a double bond. Prop 1N. And at first position there is 2 degree suffix. 1 all. So the answer is prop 1N 1 all. Should be the answer. Understood? So we will see more examples from this part. Okay. Hi students. So let's see more problems from this area. Okay. So here starting with the first example, you could see a bond line notation here. So OH group is connected to this carbon atom. So I should choose the longest possible carbon atom, including the carbon atom of the OH. So I can include that from only here. 1, 2, 3, 4, 5, 6. If I go like this. 1, 2, 3, 4, 5, 6, 7. So that looks the longest possible one. So I will choose like this. Okay. So this is my parent carbon chain. Okay. So I should number in such a way that the carbon atom connected to OH should get the lowest possible number. So let me say, so this should be 1, this should be 2, this should be 3, this should be 4, this should be 5, this should be 6, this should be 7. Now I know that at the third position you have CH2, CH2, CH3. That is 3 CH3, CH2, CH2. What is that? 3 carbon atom means prop. So it is a substituent means propyl. Correct. So what should be the name? 3-propyl, because that is the 2 degree prefix. 1 degree prefix is not applicable. 7 carbon atom means the word root is hept. All are connected with a single bond. So hepten. Then at the second position you have the functional group. So suffix 2 degree suffix is all. So 3-propyl, hepten, 2 all is the answer. Understood? Now coming to the next example, it's a cyclo compound. So again, this should get the lowest possible number. So 1, 2, 3, 4, 5. Correct? If I go in other way, 1, 2, 3, 4, 5 will come here. So the lowest possible number possible here is 1 and 3. So what should be the name of this compound? I know at third position you have a substituent. So 3-methyl. Correct? 1 degree prefix is applicable since it's a cyclo compound. I use the term cyclo. Word root 6 carbon atoms are there. So cyclohex. Correct? 3-methyl cyclohex. All are connected through single bond. So hexane. At first position you have functional group. That's 2 degree suffix is all. Hexane 1 all. Understood? Now coming to the example 3, please remember whenever two similar functional groups are connected. So here also I am numbering 1, 2. This is the longest possible chain. So eth connected through single bond ethane. So please remember whenever two functional groups, similar functional groups are there, please don't remove E. Very, very important. We have seen in the case of the other one also, correct, previous one. So ethane 1 comma 2, ethane hyphen 1 comma 2 di, both are similar, diol. So don't remove E, very, very important. Sometimes they used to say 1 comma 2 ethane diol. This is also correct. More correct is first one. Okay. Eth because two carbon atoms, ane because they are connected through single bond. First and second position you have functional group all. Since both are same, we use the term di. So ethane 1 comma 2 diol. Now coming to the last one. Here you could see the functional group COOH and OH is there. Who is the seniormost? COOH. So I will include this carbon atom in my parent carbon chain. Correct? Now I know that OH group will behave like a substituent. So the numbering, this should get the lowest possible number, 1, 2, 3, 4, 5. Correct? So what should be the name of the compound? Tell me. 4, since it is a substituent, I should start with that 4 hydroxy. Why? Because 2 degree prefix will come first. So substituent here is OH. So 4 hydroxy, then 5 carbon atoms means pent. Correct? At the second position they are connected to triple bond. So pent 2 YN. Correct? Then hyphen 1 oic acid. Correct? Because 2 degree suffix is COOH, its suffix is oic acid. So I hope you understood the concept of nomenclature of alcohols. We will see more examples in the coming session. Okay.
Yes, students, welcome you all to another session of Brainiac's Doubt Clearance. Okay, so we have the first question in front of you. So this chapter is from some basic concepts of organic chemistry. So we are dealing with IUPAC nomenclature. Okay, so the first question you can see here. So how to do the first question? So while we are doing the IUPAC nomenclature, first thing you need to check here is whether any functional group is present. So we can see here carbonyl group is present, cyanide group is present, and aldehyde group is present. And we know from the priority table who has the highest priority among this cyanide group has the highest priority. That means this group will behave like what actually? This group will behave like the functional group, and CHO and carbonyl group will behave like the substituent. Now we know that as per the rule, if a carbon containing functional group is there, that carbon should be part of the parent carbon chain. So we should choose the chain in such a way that it should be the longest possible chain. So we could see here, so this is the longest possible chain. Okay. Now let's see. Now we know that's why CHO was not included. We know that CHO here behave like a substituent, and if I choose in that path, it will be having less number of carbon atoms. So while numbering, this will get the number 1, this will get the number 2, correct? This will get the number 3, this will get the number 4, and this will get the number 5, correct? Now we know that what is the format of naming? First 2 degree prefix should come, correct? 2 degree prefix is the substituent. So we know that at the second position there is a substituent, and at the third position there is a substituent. So second position, what is the substituent present? CHO. CHO, what is the name we use? Usually CHO, we know that we can use the term for CHO, that is formyl, right? If the carbon atom is not included in the parent carbon chain, when it behaves like a substituent, we use the term formyl. Now coming to C double bond O, that is keto group. So whenever the keto groups, it behaves like a prefix, that is as a substituent, we use the term oxo or keto. Anything can be used. So here first one is formyl, then next one is oxo. So alphabetically formyl will come first. So I can write 2, okay, hyphen, there should be hyphen between the numbers and letters, formyl, correct? The next substituent is at the third position, again hyphen, 3 oxo, separated by, then comes the word root. How many carbon atoms are there? 5 carbon atoms are there. So the word root is pent, correct? Now all these carbon atoms are linked through single bond. So we use pentane, correct? Now at the first position you have the functional group. So that is the 2 degree suffix. So pentane. So we use pentane since it is cyanide. Pentane 1, then nitrile. We know the 2 degree suffix used for cyanide is nitrile. So the answer is 2-formyl 3-oxopentane 1-nitrile. Okay. Okay, now we will go to the next question. So in the next question you can see, so second question we will do. So in the second question we can see here, there is no functional group is present in this compound, there is only triple bond is present. So our rule says that try to choose the path in such a way that we need to include the maximum number of multiple bonds. So my principal chain should be which one? So I can choose this as my principal carbon chain, correct? Because this will include the maximum number of double bonds. Now, if this is the principal carbon chain, then next process I need to do is the numbering actually. So we know that it is a symmetrical compound. So if I give the numbering from left to right or right to left, it will remain the same. So let me say this is 1, this is second carbon atom, correct? And this is my third carbon atom, and this is my fourth carbon atom, and this is my fifth carbon atom. So I understood like in the third position there is a substituent. So as per the naming, first 2 degree prefix will come, that is the substituent. That is we know that CH2CH3, that means 3 hyphen ethyl, correct? Then there is no more substituent. In that case 1 degree prefix is not applicable since it is not a cyclo compound, correct? Then comes the word root. Word root means the number of carbon atoms in the parent carbon chain. So 5 carbon atoms are there, so we use the word root pent, and they are linked through triple bond. At what positions? I can say pent, hyphen at first position and fourth position. 1 and 2 is there, minimum number is 1. 4 and 5 is there, minimum number is 4. So we will write it in increasing order. 1 comma 4 pent, 1 comma 4 hyphen. Since both are double triple bond, we use the term di, then we use wine. So the answer is 3-ethyl pent 1 comma 4 diene. So here we will deal with the third question. Okay. So the third question is one of the very important question. So if you see the third question, you can see there is COOH group here, correct? So I will try to redraw also for your understanding. Okay, so it will be like HOOC, COOH is there, then CH2 is there, correct? Then another CH2 is there, correct? Then we have the carbonyl group is there, correct? Then OCH3 is there, correct? So this is a very important question. Why I am saying that? I will say. Now here, if you see here, the two functional groups can be seen. One is the carboxylic acid group and other is the ester group. So this is the carboxylic acid group and this is the ester group. Now I know that when carboxylic acid and ester is there, who will get the priority? Carboxylic acid will get the priority. So this will behave like the functional group and ester will behave like the substituent. So here is the important thing. So when ester is behaving like a substituent, so ester, if it behaves like a substituent, then then the carbon atom, then the carbon atom of the ester, carbon atom of the ester should not be should not be included in the parent carbon chain. You can see that in the priority table, included in the parent carbon chain. Okay. Why? Because whenever the carbon atom is included, we can see that for ester there is no prefix is there. If the carbon atom is not included, then only the prefix is available. So here we know that this is a substituent. So we cannot include the carbon atom of the ester. So what should be my parent carbon chain here? So I should choose the parent carbon chain. I will choose a different color. So the parent carbon chain should be this one. Correct? Okay, tell me whether it will go to the ester. No. So this should be my parent carbon chain. Okay, so this is the most important understanding here. So otherwise your answer will go wrong because ester the carbon atom is if included in the parent carbon chain, then it will not behave like a substituent. So this should be my parent carbon chain. And how I will do the numbering? The minimum number should go to the carboxylic acid group, then 2, then comes 3. So when ester behaves like a substituent, what is the naming convention we use? We use the prefix. Please remember this. This is very important. Prefix we use is alkoxy carbonyl. Okay. So here alkoxy, here alk is what? Methyl part. So we can say methoxy carbonyl. So what should be the name of this compound? So I can write the name of the compound as first comes what actually 2-degree prefix, those that is coming at the position 3. So I can write 3 hyphen methoxy carbonyl, correct? Methoxy carbonyl. In the parent chain there are 3 carbon atoms, so the word root is what? Prop, correct? They are linked through single bond, so we use to term propan, and first position you have oic acid. So my answer is 3-methoxy carbonyl propan 1-oic acid. So I hope you understood. Very, very important. Please learn this example. Thank you for patiently listening to our lectures. If you have understood our lecture, please subscribe our videos, and if you have liked our channel, please like the channel as well. Okay, if you need more lectures, you can contact Brainiacs classes. Thank you. Hi dear students, welcome you all to another session of Brainiacs doubt clearance. So we have new 3 questions in front of you. So we'll go to the first question. Okay, this is from the chapter Basic Concepts of Organic Chemistry. Okay, so in the first question you could see here a benzene is connected. So we will doing the first question here. Okay, so benzene is connected to the benzene. You could see COCl is connected. Okay, that is carbonyl halide. Correct. So here it's a most important question. Why we am saying here is functional group is connected outside the benzene ring. So we cannot include this carbon. Okay, this carbon in the parent carbon ring. But in that case, what we do is we will take this benzene as the parent carbon ring system. Okay, so we can say the name of this compound is benzene. Okay, benzene. Then we know that whenever COCl, whenever COX, generally we say COX, we use the term oil halide as the suffix. Since carbon atom is not included here, we use carbonyl halide. So here we can say benzene carbonyl chloride. This should be the name. Sometimes earlier scientists used the name like benzoyl chloride. This is also correct, but more correct is which one? Benzene carbonyl chloride. Why? Because the carbon atom of the functional group is not included in the parent ring system. So we use the term benzene carbonyl chloride. Okay, so I hope you understood the naming of this one. Very, very important. Uh, Please take care namings like this. Suppose if CHO groups comes here, we use the term benzene carbaldehyde. If it is COOH, we used to say benzene carboxylic acid. Earlier we used to say benzoic acid. For benzene carbaldehyde, we used to say benzaldehyde. But the correct name is benzene carbaldehyde. Okay. Now coming to the next question, second one. You have a ring system and you have some substituent. Now here we need to first, we know the parent system is ring actually. Now we need to number it. So we need to number it in such a way that minimum number should come. So suppose if I number it like this. Now what is the locant coming here? 1, 2, 3, 4, 5. So the locants coming here is at the first position 2 substituents are there. So 1 comma 1, 2. This is the locant coming. Now suppose if I give 1 to the other substituent, then it will come, how it will come? 1 comma 2 comma 2. So we know by first point of difference rule, here both are same. Here the lowest number is this one. So this should be the correct naming. So what should be the name of this compound? So I can say substituent, first comes the prefix. So at 1, 1 and second position. So I can say 1 comma 1 comma 2 hyphen 3. 3 are there. So we use the term tria. Then all are methyl groups. So we say triamethyl. Correct? Triamethyl. then 1 degree prefix will come since cyclo compound, so we use the term cyclo, 1 degree prefix. Then the word root contains 5 carbon atom, means we use the term pent, correct, pent. Now below I will write it in the downside, pent. Now all are linked through single bond, means I can say pentan, correct. uh, there is no other functional groups there, so I can say E. So the answer should be 112 trimethyl cyclopentane. Okay, since there is no space, I am writing down. Okay, now next question, coming to the third one, it's a very important question. Okay, so here if you see the functional group connected here is COBr. Again we know that it is carbonyl halide, and other functional group is cyanide. Then you have OCH2CH3, that is ether group, and you have nitro, which is a substituent. NO2 is a substituent. Now out of this, the highest priority goes to carbonyl halide. So this will behave like the functional group, this will behave like the functional group, and cyanide and others will behave like a substituent. So now I will choose my parent carbon chain, so it should be longest parent carbon chain. So I will choose the longest one, so this is my longest possible parent carbon chain. Now I can number it, so this will come get the lowest possible number. This is 2 and this is 3 and this is 4 and this is 5, correct. Now listen here, we have at the third position cyanide is there. Whenever cyanide is behaving like a substituent, we use the prefix cyano, and when others are behaving like the substituent, we use alkoxy. So here ethyl group is there connected to O oxygen atom, so we use ethoxy. So we have three substituents there. At fourth position, nitro. So who will come first alphabetically? Nitro is there, ethoxy is there, cyano is there. We know cyano, so we can start the naming as 3 hyphen cyano, correct. Then who will come next? Ethoxy, so we can say 3 cyano, okay. Then 3 ethoxy, correct. 3 cyano, 3 ethoxy. Then at the fourth position you have nitro, 4 nitro, correct. Then the word root have 5 carbon atoms, then we use pent, correct. Then all are linked through single bond, so we use pentan. We know that at the first position you have oil halide, so pentan 1 OYL, oil, okay, oil. Then what should come? Bromine is there, so we say bromide, oil bromide, pentan oil bromide. Okay, so I hope you understood the explanation. If you need more lectures, you can contact Brainiacs classes, and if you have liked our lectures, please subscribe our channel. Thank you.